Raymond, over to you for the panel.
Okay, so I think this is the first panel. This is actually also a recurring theme at the OAI workshop. I'm not sure we did it last time. I'm sorry. So this panel is about standards and open source software. So we've asked this question over the years, investigating and shaping the relationship. How do we make these two things work together in the most efficient way? That's one of the objectives that we always had at OAI. And it's going to take maybe a couple more generations to get the answer, I think. So I'd like to start by introducing the panelists. So you can see this is actually quite a 3GPP heavy panel. That's by design, huh? So the first panelist is our good colleague, Jimmy Alberg from Ericsson. Let me just make sure I don't say anything. So Jimmy's Director of Open Source Policy at Ericsson. So he handles IP standards and open source within Ericsson. He's chairperson of the Open Chain project, and he's a frequent guest lecturer on topics such as open source, open standards, patent commercialization at various universities. Jimmy and I met a long time ago, and our discussion was also the reason for these panels, and it led to Ericsson joining last year, which is a very, very nice thing.
What, 8 years?
I think it was 2015. Huh? So the next panelist is Doug Knisley from Qualcomm, and Doug he's currently a principal engineer at Qualcomm and a standardization delegate with various organizations. So he's a senior delegate at ORAN and co-chair of the SDFG at ORAN. He's a board member of OpenAirInterface Software Alliance, as is Jimmy, for that matter. And he's also a board member of the Linux Foundation, Networking Foundation. I guess that will come up during our discussions. Tommaso Melodia from Northeastern, well, you heard the introduction before by Adlen, so I won't repeat all of the academic part. He's also a board member of OSA. He's also a board member of the ADIS NextG Alliance Research Council in the United States, and a central figure in U.S. next-gen research. So Tommaso will give if you like, the academic component of this panel. He's very well positioned to do that. Ultan Mulligan is a colleague from very nearby down the street here in Sophia Antipolis, from ETSI, the European Telecommunications Standards Institute. And let me see if I have anything. So Ultan, he's the Chief Services Officer at ETSI. He's responsible for ETSI's external relations, software and open source groups, testing and interoperability, preparation and publication of standards, and new tools and working methods. He was previously director of ETSI Center for Testing and Interoperability, director of innovation, and director of communications at ETSI. He's also vice chairman of the Marketing and Communications Committee in the 1M2M Partnership Project. And finally, we have Joona Soininen from Nokia. So Joona, he is the head of open source initiatives at Nokia. He's board member at Linux Networking Foundation and previously board member at ONAP. So he brings a unique view on combining technical policy, government relations, managerial, R&D, and strategy tasks. Okay. So now that everybody has been properly introduced. Sorry? Now you're out of time. Okay, so the question number one, how can we leverage open source to do a good job for standards? Okay, this came up in a discussion that we had last week preparing the panel. You know, these have sub-questions, so I mean, basically, where does each, so open source software and standards have a role in the bigger picture? How will software accompany standards in the next generation? And you know, we know that open source software can help drive innovation into standards. We saw this from Ericsson's presentation this morning. It showed that very, very nicely. But how do you actually formalize that going forward? So these are all like sub things that we can talk about. So maybe we'll start in the order with Jimmy.
Yeah, so I think this is funny because this is not a new question. This question has been asked over the years, time and time again. And I think it's important to then put it into the aspect that both open source and open standards are just different modes of open innovation. They have slightly different cultures. They have other aspects such as governance, IP rules, and other things that are different between them. But ultimately, it's about the idea that by collaborating, we can create something far greater than we could individually. So these are just two different modes of doing that. Each of them, of course, have benefits and downsides, and it's about how do we leverage what each do well and bring that to the table. To me, open source has a certain speed of development that sort of comes from the fact that it's not detrimental to fork in open source. In a way, it's sort of almost expected, while in standardization, it's detrimental to fork. It's not expected that you would do it. So you come at two different speeds, two different angles, but there are certain aspects that are super beneficial from each, and I think it's great if we can have a civilized conversation on what is the benefit of each. I think, like, this is probably 8 years ago now that Qualcomm hosted a workshop in San Diego, which was a joint ITU and NGNM workshop, exploring this question. And it was funny during that time because you had open standards people in the room sort of saying, we are the only place in the world where competitors can come together and collaborate on things. Then you had open source people in the world saying, we're the only place in the world where people can come together from competitors and collaborate on things. And you realize they're both saying the same things. It's probably, both are probably true, but how can we bring these two communities together? Since then, I don't think we've seen a super good example of that actually happen. There's been multiple attempts. We learned a lot from these attempts, I think, but for me, projects like OpenAirInterface probably represents the best that we've been able to do, and in terms of OpenAirInterface, we've done great. But how do you bottle that success and put it on the source shelf, so to say? That question for me, I still really have not answered.
We can go in order.
Go next.
Yeah, go ahead.
All right, so I'll clearly bring a slightly different perspective here, being the only one in this panel that comes from academia. Just wanted to, and this is something I've been discussing also with the panelists before, wanted to make the case that open source software is an incredible opportunity for academia in this space. Right? So if we look at standardization for 5G, right? And this I'm talking primarily for the US, but I don't think that things were substantially different in Europe. So in the US, the academic community has been completely disconnected from the standardization process of 5G. Zero. I mean, I cannot think of any contributions that really went into the standardization process that were coming directly from academia. Of course, some of the fundamental research that led to some innovation was coming from academic research. I'm not trying to discount that, but there wasn't any direct involvement into the process that led to creation of the standards and some of the specific technologies that then went into the standards. Then, when in 2017, in 2018, I started working as director of research within the National Science Foundation Platform for Advanced Wireless Research Program, or POWER, was trying to build test beds, and we've heard today from OAI, for advanced wireless research, right? And they were saying, oh, these are going to be 5G test beds. And our point at that time, and we tried to make it very clear that these test beds needed to be open, programmable test beds that would help us. Obviously at that time 5G was a big thing, but it was by and large already done, so to speak, right? And so the idea was these testbeds needed to be a tool over the years that would lead the academic community to be able to participate in the definition and then going forward into the standardization that will go into 6G. Right? And clearly, OpenAirInterface, which at the time was a younger piece of software than it is today, but it was super clear to us that that was going to be a crucial tool, a crucial piece of the equation of putting together this vision to go towards 6G. So I think that there is an incredible opportunity now for the academic community to contribute to what will go into 6G, and we can do that by leveraging software that, by and large mimics what real 5G standards do today. Actually, it does exactly that. We have a good basis to modify this source code to develop functionalities that can directly inform the 6G standards. And I hope that a lot of people in the academic community will follow this path and contribute to this journey. Again, I think there is a great opportunity.
Yeah, so from my point of view, it's kind of like, it's hard to be a little bit after Jimmy here because I most probably will have similar points than him as well. But the thing is basically that if we look at standards in open source, those are basically two different tools in the interoperability and in the industry consensus building toolbox. So the one is better for one case and the one is better for other case. And it doesn't mean that you couldn't use those tools in conjunction as well. But when you look at standards basically build interoperability between different kind of implementations. And there is the idea that you build the standard and then somebody else builds the implementation compliant to that standard and they will work together, which is the beauty of standards. Open source, on the other hand, defines an implementation that is most hopefully used by big part of the industry itself to do something. So you have something like the Linux kernel or FreeBSD or OpenStack previously or Kubernetes. There are basically implementations where you get the interoperability within the industry by using the same implementation. Well, now when we look at those together, it means that, well, one doesn't really replace the other, or one cannot really substitute the other, and you cannot use you cannot use standards in every case. Trying to do an standard on how to do a good operating system kernel has been tried, for instance, and it wasn't quite as successful as doing Linux. On the other hand, as trying to do one implementation of an air interface for the whole world, that is most probably not possible either. But then when we look at the kind of like question how to leverage open source in these kind of things, and I think that very interesting points are this, what was said by you, that basically how to bring the technology, how to make it live for students, how to make it live for researchers, basically having a reference implementation that allows you to touch it and try it, because I have to say I'm an X3GPP person, and those, I think for most of people, those specifications are not that exciting, and they are maybe especially for people who are not that familiar with that technology. There is a big hurdle to try to understand how the technology works and what you can do with it, whereas an implementation of it shows you what you can do with it and lets you play with it and gets you into that kind of what else you can do with it.
Thank you. Well, I think most people have said more or less what I wanted to say. In ETSI, we've had software in and around our standards right from the very beginning. It may surprise you. Hasn't been open source, and it hasn't necessarily been handled in the best way. But there is, I think that the debate of standards versus open source is quite honestly quite sterile. every time you see an issue like standards beating open source or open source beating standards, it's sometimes one technology against another. And so you can't actually discern which process has been better. The attributes of open source projects that are championed by the open source community are very often the same attributes that the standards communities champion for their activities. So again, there's a lot of commonality in approach between both. From an ETSI perspective, what is our interest? We've recently started the concept of software development groups at ETSI. We've been experimenting with open source, hosting open source projects for some years. You'll hear a bit more about that tomorrow morning from my colleague Sylvia and Magia here. We're interested in, I guess you could say, two big picture topics. One is, how can we better improve communication between the standards groups that we have at ETSI and 3GPP and open source projects to allow one to perhaps accelerate the other. In other words, using the fast feedback loops, the speed of open source development, the fact that you have an implementation, and try and get earlier and faster feedback into the standardization process to build better quality standards faster. And that's a big picture topic for us. The second major topic that we are interested in is, what can we learn from the processes and tools that the open source communities have put in place for themselves, and what of that can we bring back into the standards development activity to try and again improve the standards development process. We know, for example, in the case of 6G, we're going to have a very significant increase in the amount of software in and around the standards in 3GPP. Can we finally treat that software as software and address it properly in the standards activities, using tools, techniques that we have borrowed from the open source community? That's not to say there's no place for open source projects there. There'll be both. There'll be the open source driven activities that we want to harness and collaborate with to the greatest extent possible, but then also we need to take what we've learned from that and apply that to the standards communities. So those are the two big pictures that we're looking at ETSI. They're rather large challenges, but we have to start.
Yeah, I think that's really well stated. Standards organizations that are going to have a future have known for some time that they've got to come together with open source methodologies, tools, and learn from the successes of open source processes. ETSI has done open source, as you mentioned, for a long, long time, or not necessarily open source in the license sense, but software that is usable by the industry. There are other success stories that predate some of the current efforts that are happening, say in OpenRAN Alliance. Broadband Forum recognized more than a decade ago that they had to go the route. A lot of their work product is essentially software, and they needed to adopt methodologies and tools and an open source type licensing model that, like the OAI license, is compatible with FRAND underlying specifications, which is what they produce. So we've seen this trend to unify and learn from each other. I think it's a done thing. I think it's past. But in our domain here, and especially affecting OAI, what's really changed is that in previous generations of 3GPP technologies, the software efforts and the research platforms were far behind the standard and even the deployments of the systems. And 4G, it was quite a bit behind. 4G was a complete reality before there were nice reference platforms. 5G, we're in some ways in the midst of the 5G build-out around the world. Maybe it's about at its peak. Maybe the peak will still happen later. But we have a solid, usable, high-quality 5G stack now at this stage, just some 4 or 5 years after the standards were completed. So in being developed, co-developed while systems are being rolled out. 6G, it's a whole new ballgame. 6G, we now know that evolving from that 5G stack, it's going to be prototyped and researched and studied in forms that will actually be able to influence component technologies that feed into 6G work in 3GPP. From Qualcomm's perspective, one of our earliest aspirations was, like Tommaso said, we have a dearth of programs in, especially, say, 5 to 10 years ago, that were generating top radio, cellular, especially cellular communication technology students. And a big part of the problem was those programs didn't have a reference platform to build on to do research. Without this OAI package, so many programs would struggle to be able to do work, because a PhD student can't cook up a 5G stack and then do their research on some topic beyond that. And so it's a really key foundation. But what has really shifted from the old prototyping and research sort of mindset has been the change in the mindset of the Open RAN community, which has now come in to build up on top of the 3GPP underlying radio specifications, born with a strategy that put open source software as an equal pillar on which they're building with the standards and with the test specifications. So they typically draw it as a three-legged stool with all three of those major components that are essential, and co-developing those hopefully in the same time frame. The ORAN Alliance hasn't been able to do it on their own, but now we've got a close partnership and cooperation agreement between ORAN Alliance and OAI to integrate those efforts. And as been mentioned, we've recently joined the Linux Foundation Networking Board with an open mission to try to get us to be unified also with that community, so that we're not in any way competing, but building one complete 5G, 6G reference platform that can be used for all these academic and R&D purposes. And that also, I think is going to go more, as Alden suggested, ETSI and 3GPP will probably also be moving into those methodologies as well, especially in 6G work. So in the next few years, I expect to see changes there too.
Okay, thank you. Maybe there'll be comments towards the end from the people in the audience. We should maybe, in the interest of time, go to the next question. How do you think the relationships between ORAN, OAI, 3GPP, and the Linux Foundation should evolve? You just started to talk about that.
Go first.
No, as I said, I'll be blunt and direct about it. We want to see cooperation, bilateral and multilateral cooperation mechanisms put in place between all of those organizations. I think that the ORAN Alliance NGRG effort has, which is looking into pre-standards discussions well before 6G work starts, has allowed vendors and academics and customers, operators, to table their ideas and concepts, and actually explicitly has a stream for looking at reference platforms. Yeah. And it's even put together a little bit of money to have some small grants to encourage this work, and Northeastern won one of those grants. It was the first recipient. And but it's essential, and that's why we were encouraging. I think we now have OAI and Linux Foundation Networking cooperation agreements. We have OAI to ORAN. One of the things that I'm advocating for is that we return to having our ETSI/3GPP workshops with OAI and start tightening those communities, and also to put a little pressure on 3GPP and maybe even ETSI to try to make their software-like products be more usable in an open source manner, to put them under a license that protects the IPR policies of the standards, but also makes them available for downloading, modifying, redistributing, and all those kind of things, which is a hole we have today in some of the software licenses. So that's one of the key elements, I would think, that will help this. But 6G, this is going to be a cornerstone, as I've already said, beaten to death.
We can go back the same way. Yeah, I think that the last point that Doug mentioned has to be handled by 3GPP. In other words, making sure that the increasing amount of software that will be in and around the standards in 3GPP has to be consumable by the open source community. That should be a given. And it's not today, we realize that. I think if you step back a little bit and look at maybe the history of the different organizations, the OAI, well, maybe less so the OAI, 3GPP and LFN, and if you might have seen any friction or tension between the organizations, I think you need to look outside the organizations and look inside the industry. In other words, what you're seeing is a reflection of competition, of maybe different commercial approaches by some of the players who have dominated perhaps the OAI Alliance or dominated 3GPP. In many respects, you know, the industry has rallied around these different bodies, these different approaches. I think we've come now to more or less a stable consensus as to you know, the place that ORAN shall have in the whole mobile landscape. So therefore I could see, certainly in 6G, far greater collaboration, far greater unity of vision between these organizations. At the end of the day, there are largely the same industry players inside each of these organizations. Sometimes the same individuals in the rooms, and sometimes they're even using the same meeting rooms in the same hotels. So they just changed the nameplate on the door. So really, you know, we've got to talk, we've got to keep aligned. Nobody wants to do the same thing twice in two different rooms and come to perhaps different solutions. That's completely wasteful of resources. Each will carve out its own area of specialization, already has more or less, and I foresee a stronger alignment and cooperation between them. It's necessary anyway.
Yeah, I think, like you said, this is not necessarily a new thing. So when 2G was made, that was something that ETSI could do. So when GSM was built, it was something that ETSI could do mostly by itself, and that was how it was built. But already when I came in as a young man to the 3G standardization, especially when the impacts of the internet and the internet protocol came to this, it was all of a sudden a situation where ETSI could, or 3GPP at that time, couldn't do it alone. There was a lot of collaboration between 3GPP and the IETF, and then there started to be collaboration between 3GPP and OMA, and then there started to be collaboration between 3GPP, OMA, and the IETF, and many others, and so on. And I think that the kind of like, it is quite clear that in the complex technical world of today, it is just not possible to one organization to do it all by themselves. And you cannot anymore kind of like just have one tool for everything around a technology, especially something as complex as already 5G is, or 4G was, or even 3G, and 6G definitely will be. Also during the kind of like, if we look at the changes in technology and the changes in how the technology develops, there will be different partners that are important in different times of these, and also the partners evolve. So there might be less of some organization that was before, and some more of some other. Or most probably more realistic is that the network becomes so the network of different organizations becomes bigger. So I don't think that even if 3GPP collaborates with these organizations, it would not collaborate less with the IETF, for instance. I'm like, IP topics are still developed there. I think that this is so I would say that, yes, these players and many others have to collaborate. This is most probably not an exhaustive list here. And it is important that all of the groups concentrate on that where they are the strongest, and they deliver that very well, and that there is good cooperation good good structure for that cooperation and as little competition as possible in these topics, but people basically, the different teams concentrate on that, what is the most important. And to do that, it means also that, like you said, it's same people going over the borders. It's you've never gotten anything good done by sending license statements to others. You have to send license statements with leather covers, which means people going from team to another, and work on the topics in the place where it's the most efficient place to work on it, and where also the competence is.
I'm not going to add much to what's been said. I mean, I agree with a general sense of what's been said. I just wanted to emphasize maybe we need to think creatively about how to create incentives for these various groups to work together and cooperate, right, and bring the best that each group can bring to the table. And maybe we could, I mean, just launch an idea, it would be interesting to try and bring together these different parties into some sort of a workshop discussing how this, I mean, there was a workshop last year at Northeast. I was bringing together the OAI community and the Orange software community. I thought that was very helpful. But even beyond that, you know, even bringing in the Linux Foundation and focusing the discussion specifically on how can we together contribute to accelerating the work that will go into standardization for 6G, right? I think that articulating a clear goal towards 6G could be very, very helpful.
As said, there's not much to add to the excellent things that's been said, but if I'm trying to summarize my feeling is that I'd like there to be a much closer partnership between these organizations with sort of where we can do the right work in the right space. Also a reflection, hearing Jonna talk about the good old GSM days, is that sort of as the amount of organizations necessary to standardize 2G, 3G, 4G, and 5G, and 6G has sort of grown, the amount of companies providing RAN infrastructure seems to have sort of lessened. I don't know if that's a necessary relationship, but it's kind of interesting as sort of the complexity of the standardization has increased, those offering products on the market has sort of decreased in number of companies.
Thank you. And the last one, I mean, we're just going to dive a little bit deeper into the comments that Tommaso made at the very beginning. You know, for us at Eurocom, open source software was the easiest way to prototype and also to share what we're doing with industry. That we realized very early on. That's why we did it. Christian spoke about that this morning. And it's really about, in some sense, bringing the standards into the schools. Schools don't really look at standards very much. At Eurocom, we did at the beginning. That was one of the things that Christian and also some of the other professors at the time were doing in the 1990s. Not with prototyping. That was teaching the systems from the standards perspective. But if we look at OAI now with its global reach, I mean, this is something that is very impressive, at least for me, how far we were able to reach out. Clearly, the ecosystem is going to benefit from the knowledge gained by young people that are actually using OAI and things like it. Because some of those people are going to go and transition to industry at one point in their career. I think very likely now the ones that are working with something like OAI, it would be after even their PhDs or postdocs that they would make that transition. Because it takes a lot of studying to actually understand this stuff. So, you know, the question that we have is how can we work even better to influence the standards through initiatives like OAI or the stuff that's going on at Northeastern and in other universities. I mean, these things are definitely going to make an impact just by the people that will transition. But how can we even work better together to to align the activities going on in schools with all of these standardization activities. I don't, maybe.
Okay, I'll take a stab at it. How can we work better to influence the standards through initiatives like OAI? If I were to view this as the lens of the academic, that I'm absolutely not, I'll just pretend to wear that hat and you tell me why I'm wrong. I mean, if I draw from the experience from Ericsson, one of the things we gain from being in open source projects and open development projects with our customers is, get a feel of the pulse. What do they want? What are they interested in before that comes to standardization or before that comes to commercialization? And I have a feeling that by having industry involved in projects like OAI, together with academia, having the students engaged, you get a feel of that pulse. What do we care about? What are the hot topics? And helping build that network. And also moving into having worked together in OAI or other open source projects with academia, that could oftentimes lead to more industrial PhD positions, more research collaborations, which in turn, impacts standards by the research done early. That would be my quick take on this. Note, I'll take off my pretend academic hat and leave it to the actual academic to answer this question.
Well, so I don't know that we have all the answers, or we have even partial answers today in academia. What I think is crucial for our field, and we're seeing that we have more success when we do that because the students are more interested, is to bring an experimental component into the curriculum. That is something that is absolutely crucial when when students these days see courses in wireless and in networks that are taught in the traditional way, they are less interested, and that's something that we're seeing very clearly. Now, bringing a lot of it's also challenging, right? Because we talk the whole day about things that are super cool, automation, AI, softwareization, etc. These things are not easy, right? And it requires a level of specialization and understanding of some of the technology that it's, it's tough certainly for an undergraduate student, but it's also hard for graduate students, especially at the beginning, right? They have to invest a significant amount of time during their masters and PhDs to start mastering all of the and then that part of that is that it comes from the fact that we don't have well-established blueprints where I was talking with Serdal earlier today, right? Ability to instantiate a functioning OAI network at the click of a button. It's something that doesn't yet exist today by and large, right? We're going in that direction with several different efforts and projects, but it requires a lot of legwork, and it's hard even for us because we're splitting our time between research and administration and teaching to have the time to put together good material for students that can teach in an effective way all of these skills. So I think it needs to again be a community effort of shifting a little bit the culture of how we cover certain materials and how we create a community of even of students that recognize one another as being peers in having skills that can be marketed because they're well understood to be important and needed.
Yes, and I was, while listening to the previous speakers and looking at this, trying to think about, okay, what can I say? Like Jimmy, I'm also from the commercial side and from business, not really academia. And I started thinking about a little less than 10 years ago, I did my PhD at the same time as I was working, which had the great impact that I had to actually go to some lectures and meet actually some young people. And that is, of course, very scary, but you get a little bit different perspective to to their minds. And one of the courses that I had to take was a practical course of network programming, which was basically you had to implement a rudimentary browser. And when we had then the kind of like last session when everybody got to present their implementation and stuff like that, there was then the lecturer asked that, well, what did you think of this course? And there was a young man who put his hand up and said, like, this course is nothing like reality. You'd send us one RFC and said implement it. In real life, when you go to a real company, they give you exactly a good specification of what to do, how to implement that, and you just do it. I think that young man was up for a rude awakening when he joined the workforce, especially as I have seen him actually in the corridors of Nokia. I kind of like tried to think of that when I would go and ask him, so how much has your kind of perception changed? One of the things is really that important of getting both students and researchers in this kind of like in the areas where we have very strong how would I say, where we have very strong commercial research as well, big deployments, and the kind of like there is a complex world out there. I think that more concrete that you can make it, better kind of like better quality students you get, better quality kind of employees you get, better quality research you get, because you actually have to see what are the constraints. Like what you said, Thomas, so it's like you might think that deploying a 5G network is something that you put little base stations there, you press a button and you have a network. That is sadly not the case. But as a student, you might think that is, by now, they must have kind of solved all that. Well, we haven't. And the thing is basically, well, maybe that young student, when he understands or she understands that how difficult it is, they come up with something cool that will solve that problem. And that way they work on problems that are real, and they don't work on problems necessarily that are kind of like that have less connection with the real life. Not saying that long-term research wouldn't be important and stuff like that, but it's good to understand and have some hands-on experience on how the world works. And I think this is sometimes, and this is my very badly veiled criticism of the academic world, sometimes you see research that is, you look at that must be academically and intellectually interesting, but has very little to do with the real problems. Having something like this, like OAI and available, brings people closer to that, what is real and what is tangible.
I think, well, this statement that's here in front of us, you can see it as well. There's really two questions. Bringing standards into schools, in other words, making sure students are exposed to the state of the art in terms of technologies, that you actually have a relevant learning experience for when you go out into industry. And the second thing at the end is influence the standards. There I might say perhaps, let's have some realistic expectations. But in terms of bringing standards into schools, about 10 to 15 years ago, I was involved in ETSI trying to develop better links between ETSI, the standards communities, and the research activities that were in Europe, and in particular the European Union funded research activities. At the time it was Framework Programme 7, and Horizon 2020 I think was just beginning to start. I was quite shocked when I looked at a lot of the communications research that was ongoing there. Much of the software that people were using, much of the boards and kits that people were using were all Wi-Fi based. There were some people beginning to play with 4G, and nobody was really looking at 5G. And this was at a time when we had already locked down the 4G standards in 3GPP 2 or 3 years earlier. So it was kind of late to start 4G related research in an academic community. And yet that's what people were beginning to try to do. So that was very disappointing. But when I look at what we've done with the 5G public-private partnership, and the 6G SNS joint undertaking, where we have very strong links between industry and academia in Europe, building collaborative projects, working together. You see a better cross-pollination between the two. You see, okay, perhaps not everything coming out of a research project is relevant for standards, but you do see the industry being very interested in certain particular nuggets that are coming out of research. And of course, the opposite direction is working very well because they're working closely together. Then you see the research community actually having, the academic research community having access to the latest tools, the latest software, the latest demos and kits to really have relevant research ongoing. So that, I think, is something we're beginning to do right, at least in Europe. And at the time, actually, I remember it was noticed that even in the US, they weren't managing to get this relationship between academia and industry done quite as well. However, when it comes to influencing standards, I think, again, have some realistic expectations, in particular when it comes to influencing 3GPP. There are some standards communities that are much more easier to influence. Something like 3GPP, I mean, it's a multi-billion euro industry is built on the back of those standards. There are some very large corporations there, both in terms of vendors and in terms of network operators. There's huge stakes. And therefore, there's very strict control as to what goes into those standards, because what goes into those standards will have an impact on products coming out at the other end and will have a cost impact. So be realistic in terms of your expectations of trying to influence those kind of standards. And also don't forget that the timescales might not match what you have in terms of your research community. You saw the slide this morning from Ericsson where they were showing the timescales for 6G. In about a year, year and a half, we're going to start the study items for 6G and 3GPP. 2 years after that, we're going to start the specifications for 6G. 2 years after that, they will be finished. Of course, 6G doesn't stop there. It continues to evolve over the following 10 years. But in a 4-year space of time, we'll be doing the studies and then the specifications for a mobile communication system, which will be the main mobile communication system from 2030 to 2040, and will probably stay running in the networks live until about 2055. So you can see the kind of care that needs to be taken as to what goes into those standards. Their stakes are rather big. But the speed at which 3GPP will work may surprise you. And don't forget that. People say standards are slow, but then you look at 6G, it'll be done in 2 years. 2.5 years.
Yeah, I would also add that this is already happening, the better integration. And one thing that maybe you didn't want to brag about, I think this concept of DApps that many people have heard about coming out of Northeastern University has been brought into NGRG discussions in ORAN Alliance and has received a great deal of interest and support from companies. And the other thing that I think is going to be perhaps the most fruitful academic standards partnership and open source, actually all together, for the 6G research phase and study phase and standards specification phase is this whole notion of native AI, AI/ML being applied throughout every aspect to a cloud, for the first time, a truly cloud native architecture. And those are areas which are reachable by students. It may be very challenging, for example, to become a physical layer coding and modulation contributor at the 3GPP level, because the bar is so high on the underlying simulation resources and standards support resources and everything else that's necessary to go and get ideas incorporated into the standards in those areas, because, as Alton mentioned, it is it's a fusion, almost a fusion reactor for a giant industry that's making very crucial decisions. But the areas that are around network automation using AI/ML for 6G networks, and even automation of things down at the XApps, DApps area, and the ideas that are now being under discussion for the restructuring of the RAN itself. I would urge anybody in academia to take a look at the early discussions that are happening in the NGRG, which is open, by the way, even to non-ORAN Alliance members on a certain basis by signing an agreement. And also the workshops that are held at each of those events, which have had many presenters from academia involved, some in the room giving talks. The next one will be in Montreal in October at the ORAN meeting. But as I said, I'm very optimistic. I do believe for 6G, academia is going to be up right pretty close to at level with the research work that's happening in many areas of 6G. Not all. Some of them will be driven by large, well-funded research teams in major vendors and operators and things like that, and require that kind of funding level to do it. But when you look at the opportunities that are out there now for grant money that's available in the United States, certainly, and hopefully more and more in Europe and other regions, which, some of the organizations in the room are already applying for and, jointly applying with OAI in some cases for grants that are coming out, and, the NTIA grants that are happening now, and the third wave will happen later this year, we believe. So it's a golden time to get involved, and we just, really applaud the growth of so many of the universities that are in this community, that coming out of Powder and other affiliations.
Yeah, may I just answer that? The one thing that I kind of maybe didn't hear or missed here is that kind of academia has always had a big influence on the different generations of mobile communications. You said about the frame projects in the European Union and so on, and especially in the kind of pre-standards time, many universities have had a key actually impact on even in the radio interface, in many parts of the network and so on. And this is and there has been a big cooperation between industry, the government, and the academic sector in kind of in those things on bringing the technology forward. And there has been even a big exchange of, again, leather-covered books. So people between academia and the industry in those kind of places where we have people that have used to work for a vendor or operator now works in academia, or the other way around. And of course then all the time students coming into the company. So there is a long history in this, and I think that this is, there are ways to, the kind of academia does contribute a lot to these.
Thing on that, so in one of my previous roles, were involved in all of Ericsson Research academic collaboration agreements. And I mean, we sign more than 200 of those a year, invest significantly both in terms of money, but also man hours into those. We would not do that if that was not beneficial for our standardization efforts. Right? It's crucial for them. So academia does have an impact, even if we aren't seeing the name of a university or a university professor necessarily on the contribution line, that the research that builds on, that certainly has come from academia and resulting of this partnership.
Yeah, that's a great point, Jimmy. I totally second that, and I testify to that. When I was at Ericsson in Lund years back, there was a very strong collaboration with the University of Lund professors. The entire team, corporate research team, used to go and spend time attending lectures and seminars at the university. And this happens all the time in the universities in California and other places also. So yeah, that's very. I think we have covered the topics that Raymond wanted to cover. He had to step out, so he handed this over to me. I know that there are many questions. Well, Florian has one.
Thank you. Yes, so I want to go back to question 2. I want to dig a bit deeper there. So I welcome the collaboration that you mentioned between ORAN and 3GPP, but I wanted to dig a bit deeper and see, and especially on the topic of AI ML. I want to ask you and the other panelists as well, what's your concrete vision on how these two organizations should work together? Because in the past few years, they haven't really. I think 3GPP has quietly ignored all of the good work that happened in ORAN. So I'm not quite sure how that's going to work out. Well, the good work that happened on AI ML in ORAN.
Another activity that is openly going on in ORAN Alliance right now is a preparation for cooperation with 3GPP. We have a series of internal meetings trying to figure out how we're going to cooperate, and at our last ORAN meeting in particular, we had several RAN, SA, and CT chairs that spoke at the ORAN workshop. And there is now emerging plans to try to have a joint workshop between 3GPP and ORAN to try to avoid any sense of that divide in the future work, especially the 6G work. There's a more openness and more sense of 3GPP recognizing ORAN as a peer standards development organization. I would say it's not as bad as you may think, because the ORAN member companies are still some of the leading companies in 3GPP, and a lot of ORAN design decisions have informed many contributions and many CRs in the 3GPP side of the shop. For example, in the OANM, between the, say the things that influence the elements that go into O1 interface and the ORAN side that come out of 3GPP, that it's the same chairs on both sides. That's pretty well coordinated.
Right. But there's other work.
Now, for AIML in particular, on the surface, the AIML may look disconnected because both sides have adopted different terminology. But as was concluded in a study that happened a couple of months ago in ORAN on a sort of gap analysis between 3GPP and ORAN on the AIML area and what that means for the rest of 5G and for 6G, the conclusion at the end of the day was there's very little overlap. It's quite complementary, even when they're working on the same particularly narrow areas like analytics. The work that's being done in 3GPP is all informing the design in ORAN. And the ORAN RIC and other elements and the automation architecture around that's being formulated in ORAN really has been designed with the 3GPP underlying architecture in mind, and even the AML. There are a couple of areas that, like sort of ML ops, if you like it, the ML workflow that's being done in both organizations. Our opinion in Qualcomm to a large extent is that both of those are actually doing work that's going to be probably decided by the cloud industry and by standards outside of either organization for the most part. And actually largely based on open source tools and platforms that'll probably be doing the ML operation, ML lifecycle, if you like, whatever kind of terminology you want to use. So I think, again, both the 3GPP and the ORAN need to get more in sync with the parts of the industry that are defined more cloud native, and that's most prominent in AI/ML area right now. But there's a lot of work to do. Don't get me wrong. I'm not trying to trivialize it, but we are reaching out, and I think the cooperation is only going to get better as we look forward to 6G kickoff work in early 2025.
Thanks.
So I'm going to be a bit of a Debbie Downer here, okay? The telecom industry is not great right now. There's this general sense that every 10 years, operators are being asked to upgrade their networks, $500 billion to upgrade every generation. Everything is getting more softwareized, like efforts like OAI is helping a lot with that. Like, I mean, do we even need, okay, 6G is going to happen because it's almost there, but will we need 7G? Like, will it be developed the same way?
Yeah, I mean, like, most probably you're right. The world will stop and we will never develop anything again. That's very likely. No, really, I had a discussion a long time ago. I was working for another company at that time that will 4G be the last G? Well, it wasn't, and neither was 5G. The kind of like, well, who knows how these are going to be developed? Will 3GPP, will they be doing the 12G in kind of like, and that will be very academic question for me at that time. But the thing is basically that the technology will go forward. It's very clear that telecommunication, mobile and fixed communications are really important for the world, and the world will not get less networked in the future. The requirements on the networks are getting harder and harder, so which means that we have to get more bits per hertz. We have to get bigger allocation for spectrum. We have to get better networks. We have to get more ubiquitous networks and stuff like that to support the new applications of the world that need communication, and all needs communication nowadays. We're not going to go to a world that will be completely PCs that are not connected to anything anymore. So the thing is, we need to continue to develop these networks. If we don't develop new networks, if new networks are not going to be deployed, then the evolution of technology in other areas will slow down as well. So I have no doubt in my mind that there will be something after 6G. How that will be developed, who knows? But now it might be driven by 3GPP, it might be driven by somebody else. It's actually not important. The important thing is it's done in the kind of like best possible way for the world, and it will have the best reach. Until now, that has been 3GPP.
I just think it will not be humans creating the standards. It will be the models creating their own standards to talk to one another.
But just a short reflection, because when we're doing the research for 5G and leading up to that, I know that at least internally in Ericsson, we're very, very cautious. Do not call this 5G. It's not decided that it's going to be called 5G. It's NR, right? It's new radio. Today, we're already talking about 6G, and we're talking about 7G as well. So do I think there will be a mobile telecommunication standards after 6G? Absolutely. Do I necessarily think that we'll call it 7G? Possibly not. Possibly there's been enough bad publicity around this upgrade cycle, around all of that, a name change is needed. But I definitely believe that there are telecommunication standards beyond 6G, absolutely.
Yes, and even in the case of 6G, there are operators who are, telling people to, slow down, that any 6G network has to be, a software upgrade of what we already have. So you get these kind of tensions. I think you also need to, again, disconnect what are technical issues and maybe related to the standards that could be solved by standards or by another generation of standards, and topics which are nothing to do with standards or technology at all. I mean, this industry is cyclical, first of all, so we're going through a cycle. Cycles, we have downs and we have ups. This industry is heavily regulated, and there are maybe structural changes that might happen. I mean, you've heard complaints from network operators about how competition is managed in Europe, that they want to allow them more mergers of networks and that sort of thing. It may have relationships with spectrum licensing, how that's managed. That tends to add a lot of upfront cost to a new network operator. It's also a barrier to entry for any competing network operator, so there's two sides to it from an operator's point of view, but there may be changes there. Those topics have big impacts on the profitability of a network operator and the profitability of the industry as a whole. Whereas topics related to the cost of deployment of a network, the cost of operations of a network, they're topics which can be solved in the standards. But topics related to licensing, regulation, it's nothing to do with the standards community. There's nothing we can do to help them or alleviate them. You hear a lot of bad press, you hear a lot of difficulties, layoffs in industry and whatnot. You've got to look at what are the issues and what's our responsibility towards that.
I would also say there's been this recent fad, kind of like the end of science a few years ago, that said we're at the end of data communications, right? They're saying that nobody needs any more than 4G LTE mobile broadband, and that nobody's going to need any more data rate because it's enough to carry 4K video, and that's all we need, because that's all the internet is people watching video streams. I think that we have no idea what the next wave of driving applications is going to be. I think it has to be a little bit of a matter of faith. I think AI/ML is going to drive use cases that we cannot conceive of today. For 5G, we laid out this thing. The model use case was always going to be remote surgery. We had to have ultra low latency so you could do remote surgery. Well, there isn't any remote surgery. Everybody knows that. And so now people tend to try to stay away from mentioning remote surgery because it became kind of a joke in 5G. So we make up other use cases in 6G. There will be use cases, and that's why I think we don't know how pervasive AI/ML native networks are going to be, both for AI over 6G and 5G and AI-based 5G and 6G. We just don't know yet. As far as the Gs are concerned, I think the ITU has done a horrible disservice in setting this 10-year cycle and forcing an arbitrary G on a cadence. I think it's not helpful, and I think we should get away from it. I think it should be an evolution. If you look at 802.11, it just keeps rolling out features, right? They just keep rolling in new things, and it seems to really thrive. So. No, those are like just versions, right? They're very, very stepwise. Well, I don't see them as our kind of Gs. Our Gs are a much bigger deal.
I think we're going to have to wrap up the panel session. As always, this is a very interesting subject. So I'd like to thank all the panelists again. Get all